Hi, my name is Marianne Simon, and I am your G3 instructor for today's module on doing a site evaluation and an irrigation audit. So let's get started. Share my screen. There we go. All right, this is the module on doing a site evaluation and an irrigation audit. Okay, so there actually are two components, or rather they overlap a little bit. So yes, the focus is on doing an irrigation audit using catch cans, but the way we do all things watershed wise is you can't do that without understanding the greater context of the site. So we will be focusing specifically on the audit, and then we will be expanding our view a little bit more. So the site evaluation, again, is the big picture. What do you notice just, by looking around? What is a visual audit? And then we will be paying specific attention as to what do we need to look at rainwater capture opportunities. So that is the game plan. Now, to help you along the way, we have created a little form, a mini watershed site evaluation data collection sheet. So pretty much you can take that out into the field. It asks all the questions that I'll be going through today. You answer those and you are almost home. So an irrigation audit is basically determining the distribution uniformity of a spray irrigation system. Now, you can do them with drip, but for the purposes of today's exercise, we're just going to be focusing on spray. So I'm going to read the definition of a distribution uniformity. It is the measure of the uniformity of the application of irrigation water over a defined area. It is the percentage of the 100% perfect irrigation system. And of course, no irrigation system is perfect. So pretty much the objective of doing these is to go out to a site, turn on the sprinkler system, and find out how efficiently that irrigation system is working. Now, during the audit, again, we'll be working with catch cans. You're going to capture water. You're going to take measurements. You're going to log it in. You're going to analyze that data, do a bunch of calculations. And then when you are done, you will actually come up with a series of numbers that will let you know how efficient your irrigation system is. Now, before you begin the audit, you actually want to make sure that that irrigation system is working as well as it can. It may be that down the road you're going to recommend some changes, but you do want to make sure that what you have is actually working as efficiently as possible. So if you have broken heads, you want to fix them. If they're pointing towards the car, you want to make sure it comes back, it points back towards the lawn. It's possible that there are clogs in the nozzles, or that they're actually sunk so low beneath the grass that it's not getting high enough to be able to water where it is supposed to. And then a very common thing that you'll see are mismatched spray heads. So you can mix some brands, they'll be interchangeable, but not all of them. And you do want to make sure that the spray type and the gallons per minute stay consistent. And then go ahead, look a little further afield. What is happening with the valves? Are they leaking? Are they rusting? Are they actually buried beneath the soil? So any of that you can clean up or make work a little bit more efficiently is a good idea. And then you'll go ahead and bring out your materials. Now, most of the things here are pretty standard practice for a landscape professional. But if you don't have a catch can kit, those are really easy to find at most irrigation or landscape supply stores. You'll want a minimum of 16. Most of them have easily probably double that. So you will get more than enough catch cans to run your audit. And then you're going to start measuring the site and putting together a base plan. So it's actually really easy to use grid paper, makes it easy to draw the lines. That's how I work, as well as keep things in scale. So obviously you're getting the irrigation audit area, but you also want to make sure, are there any surrounding buildings? Is there any hardscape you want to note? Put down your dimensions because you'll need that to calculate your precipitation rates later. And then go ahead and take that closer look at the irrigation system. So you may need to turn it on so that you can flag where the actual sprinklers are, but then also you're noting all the other relevant equipment. So where's the water meter? Where's the controller? Where are the valves? Is there a backflow preventer or a pressure reducer? All of those items you want to go ahead and mark, as well as what are the different hydrozones? Because potentially, if you're doing these for real, it's not just the audit, but you would then be auditing all the zones. I mean, it is the audit, but it's not the audit for the class. All right, next up is what are the wind conditions? So before you get too far down the road, if it is windy, you may want to go ahead and make sure that it's not too windy to run the audit. So basically 5 miles per hour is your limit. It's logical, right? If it's too windy, you're going to start to get weird things happening with the spray heads. And so there's this tool called an anemometer, and you hold it up and it whirls around and it gives you a reading. If you're under 5 miles per hour, you're good to go. If not, you may want to come back the following day. And mornings are actually typically safer for that. Now, when it comes to the irrigation audit, it is more than simply catching water in a can. Again, you want to understand the conditions that you are running the irrigation audit under. And usually one of the things that's helpful is to imagine that you are programming the controller for that area. So what information would you want to gather? First off, always first off, is what is happening with the soil. So go ahead and get yourself a little handful, do a hand test so that you can determine the soil type. That's probably the first or second question they're going to ask you. Then you're going to pull out your handy dandy soil probe so that you can see what's happening below the surface, right? It allows you to see, are there layers of different kinds of soil in there, different types of soil? Is there visible compaction happening? And then really important, what is happening with the roots that you are looking at? And then as far as the actual area that you're going to be irrigating, take notes about that. So what type of grass is it? Is it cool season, warm season? Is it some sort of mix of the two? What is the condition of that grass? Are there areas that look stressed or brown? All of that you are jotting down notes for. And then if there's any kind of slope, you want to get some sort of read on that. Again, that's going to affect your timing. It will potentially, depending how steep the slope is, affect your DU results. And then what are the microclimates? Is it sunny? Is it shady? Is it sunny in the morning and then shady in the afternoon? All information that you are gathering. And then if you are near any kind of hardscape, what can you tell just by looking at it? Obviously, you'll see a lot more once you start running the irrigation system, but there may be clues that you can pick up on right away. And then is there damage to nearby buildings? And we see this all the time when spray heads are right up against a building or they haven't been maintained properly, and all of a sudden they are actually watering the building instead of the plants. Then what type of sprinklers do you have? Do you have rotors? Do you have the conventional spray ones? Do you have maybe those new rotary nozzles, or not so new, the multi-stream trajectory nozzles? And now you're ready to start laying out your catch cans. And there is a logic, a method to that, which we're going to walk through in just a moment. But one of the things I wanted to point out is the minimum number of cans. So for this exercise, we're just doing it with 16. Some places will recommend 24. I've seen other places that will recommend 20. As far as we're concerned, 16 is the minimum. It will get you what you need. And that being said, that the more cans you have, the more specific data points and information you will be able to gather. So I'm going to take you step by step through this. This is the irrigation layout that we're going to be working with. We have sprinklers and they are 12 feet apart. So the first catch cans that I put down are the ones that are by the sprinkler heads. Typically, you want to be about 2 to 3 feet away from the sprinkler head, as well as a minimum of 2 feet away from the edge, especially if there's hardscape. By putting them in this location, you are really maximizing the amount of water that is going to be able to get to them from the different sprinkler heads. After that, you're going to go ahead and figure out what is halfway between the catch cans that you've just put in place. So you can see that we go halfway between the catch cans that are by the sprinkler heads, and then we actually go halfway between the rows. So I've got one row at the top near my sprinkler heads, I've got another row at the bottom by the sprinkler heads, and then I'll go ahead and put a third row that is halfway between those two rows. And I actually have a total of 18 heads. Catch cans, excuse me. Now, as part of the drawing, you went ahead and put in where the sprinkler heads were. We're also going to go ahead and ask you to indicate where the catch cans are. So if you've got 18, 20, 24, 37, you want to put all of those on your drawing, and then you want to number them. And the reason you want to do that is at some point after you you're done with the test, you're probably going to see areas that need a little bit more attention. Either they got too much water or not enough water. And so you're going to want to be able to find those places, those locations again. And by numbering your catch can, that helps you keep track of that. Now, just about any irrigation audit that you look at online is going to be a nice, tidy rectangle or square area because it makes it easy to figure out where to put the catch cans. But we thought it would be helpful to give you an example of what you can do when it's not such a simple area. Those not so simple areas are harder to irrigate, and most of the time there are going to be issues with how they are receiving their water. So I took this sample layout from a site online, and then I went ahead and laid out the catch cans. And again, the philosophy is the same. You're no closer than 2 feet to any given spray head. And then you try to lay out those cans in a way that is going to give you as much coverage of the area as possible. So again, the spacing is 2 to 3 feet from any given head, no closer, I would say 2 feet from any edges. If you're working with rotors that cover obviously a much larger area, the formula is a little bit different. So if it's rotors that are closer than 40 feet on center, instead of going halfway, we're going to go every third. If the area between rotors is greater than 40 feet, then you're actually going to divide that up into fourths. We're almost there. So a little bit more information that you need to gather, and that is the pressure. So the easiest place to find that is at the hose bib. You want to find out what the static pressure is, which is when the hose bib is not turned on. And then you also want to know what is the dynamic pressure, which is what happens when we turn the hose bib on. And then the other thing that you're going to want to do is read the water meter before you start the test. This whole process is a whole lot easier if there's more than one person, but if not, you're doing a little bit of running back and forth. Now, sometimes that water meter is not accessible. And the reason we look at the water meter is that it's going to help us figure out how much water actually was distributed during our irrigation audit. But if that's not possible, there are calculations that you can do that get you pretty darn close. So every manufacturer has this for their various nozzles, but basically it tells you what the gallons per minute is per nozzle pattern and per obviously type of spray head. So for this chart, we're using 15-foot matched precipitation rate spray nozzles. And you can see for each of the different patterns, there is a range, and that range is dependent on what the pressure is, that PSI number. So for our quarter nozzle, it goes anywhere from 0.65 to 0.92. For our half nozzle, it goes from 1.3 to 1.85, and so on. So when I have that information, I can actually do the calculations, and it's kind of mind-blowing. I mean, I've done this for homeowners, and it was like, holy cow, we had no idea how much water we were actually using. So what you do is you count up the number of nozzles that you have in the different patterns. So we have 4 quarters and we have 2 halves. The gallons per minute for my quarter was 0.92 because I'm at 30 PSI, which was the high end of the range. I'll just show you that. So it was 0.65 to 0.92. So I put that in, I do the math, and I get 3.68 gallons per minute. Then I'll do the same thing for my halves. Those, I'm going to go ahead and use the 1.85 gallons per minute. I have 2 of those. I do the math. I get 3.70. I add those together. And for my zone, in 1 minute, I'm using 7.38 gallons per minute. Now, we wanted to show you in comparison what happens when we use those rotary nozzles, those multi-trajectory nozzles. The numbers are pretty different. So for a quarter, we're between 0.42 and 0.58. For a half, we're between 0.75 and 1.11. So the numbers are quite a bit lower, but notice that the pressure is higher. It's between 30 and 55 PSI. And the optimal is about 40. So we do the math again. This time we end up with 3.82 gallons per minute. So about half of what we were doing with those MPRs. Now, what we want to point out is it's not as though we're using less water, because the plant still needs the same amount of water. The question becomes, how efficiently is that irrigation system working so that we waste less and are able to apply more to the plant itself? So again, same amount of water is needed, but what it means is we'll actually need to run it longer, and it will be applied more efficiently. So it gets applied more slowly, which means that the soil can absorb it better. And due to its pattern, we don't lose as much to evaporation. So it is an improvement on the conventional spray. Now, we had mentioned that you're getting dimensions because you're going to need to get your areas, which you will need for precipitation rates. And Pamela takes you through those calculations in another module. But we thought we'd include those formulas here. I remember square and rectangle, but not much beyond that. And then, of course, every now and then you get your irregular shapes as well. So yes, you can use Google Earth. You can divide an irregular shape into more recognizable shapes and then calculate them. And then if you really want to, there's something called Simpson's method. I took a look at it. It was a little overwhelming for me. Okay, you are ready to turn on your irrigation system. So you turn it on and you're going to allow it to run for about 10 to 15 minutes, depending on the type of spray that you are working with. So if it's the conventional, it's a certain amount. If it's those rotary nozzles, you're potentially running it a little bit longer. So what we're looking for is 20 milliliters or 1/4 of an inch. We want to make sure we're capturing at least that much water in most of the cans. Now, the other thing that you want to do while it's running is you want to measure the pressure again. And this time it's of the spray heads. So if you've got a pop-up sprinkler, you're going to go ahead and use a pressure T. And if you've got a rotor, then it is something called a pitot tube. So you want to measure it at the beginning, and then you want to measure it at the end of the zone so that you can see how much pressure is lost by the time you get to that last head. And once again, you are writing down, recording any observations. So is there any obvious misting? Are you seeing runoff? If you see runoff, calculate how quickly that happens, right? It could be as short as 3 to 4 minutes before you start seeing water run off the landscape. And then Once you've hit your minimum capacity, your time or your amount, you turn it off. And then you want to read the meter again, because the difference between those two numbers is going to tell you how many gallons you actually used during the audit. If you don't have access to the meter, all you have to do is take that total zone gallon per minute that you calculated earlier, and then multiply it by the number of minutes that you ran the system. So in this case, we ran it 15 minutes. 1 gallon was using 7.38 gallons. 15 minutes were up to 110 gallons for 6 sprinkler heads. And then the last part is to gather the data. This is another way or another place where it's really nice to have a second person to help you. What you do want to make sure is if there is more than one person, that it's the same person who reads the cans each time. Otherwise, they can be interpreted a little bit differently. And then you just want to work really slowly, deliberately, and logically. So you start at catch can 1, you read the amount, you record it. We actually recommend recording it on the drawing and then transferring it later. For me, it's just a way of double checking that I am capturing the information for the correct catch can. A good practice is that once you are done with the catch can is to dump out the water and then turn it upside down so that you don't forget that you've actually read that catch can before. The other thing you want to do when it's happened is make sure that you are walking through the zone carefully so you don't accidentally knock any over and lose your data. And then once you've gotten all of that, you're going to go ahead and fill out the data sheet. Again, Pamela will take you through the calculations in another module, and you are just about done. Make sure as you're wrapping up the audit that you've got critical information like the location, date, time of the test, all the information about the irrigation equipment, especially the sprinklers. So what model, what nozzle size, what type, etc. And then how long did you actually run the test for? Okay, so now you can breathe a little bit easier and you can step back and take a look at the rest of the site evaluation. Or maybe you actually do this first. The order is up to you. But we're going to focus first on what are the rainwater capture opportunities. Which means if there is a building, you want to take a look at the roof size. So you want to go ahead and measure that. And in looking at it, are there any downspouts or is it just a sheet flowing onto the ground? If there are downspouts, how much of the roof area is actually flowing into each of the downspouts? Because that will make a difference in how you recommend your rainwater capture suggestions. Other things that are critical, not just to rainwater capture, but to the health of the landscape, is the infiltration rate. So there's 2 ways that you can do that. There's one using a piece of equipment called a penetrometer. And basically you push that into the ground and you can feel it, but you'll start to get a reading. Obviously, if it's green, it's moving through the ground. At the point it starts to hit the red, then you have hit compaction and you can read at what level and how significant that compaction is. If you don't have a penetrometer, you can do it the old-fashioned way, and that is to dig a hole and see how quickly it drains. So pretty much what you're going to do is dig a hole, typically about 12 by 12 is perfect, and you're going to fill it with water. It might actually be a good idea to do this before you start the audit, because sometimes this can take a while. But what you do is you fill it with water and then you let it drain all the way through, and then you fill it with water again. And the second time around, you're actually going to time it. If it takes about 2 to 4 inches per hour to drain, you're in great shape. If it drains a lot faster than that, you probably have sandy or looser soil, and you're going to want to do some mitigating. If it's taking longer than that, if you have to come back tomorrow in order to see it drain, then obviously you have issues with compaction or infiltration, and you will want to plan on mitigating those as well. And then take a look around. What are the other clues as to the health of the garden? So what do your trees look like? If there's large shrubs, how are they looking? Are you seeing ponding in areas? Are there signs of erosion? Anything that's cracked or broken or collapsing? Those are all good things to note. They're clues. Are you finding any fungi out there? Basically signs of biology, could be earthworms, pill bugs, mushrooms, what have you. All of that stuff you want to jot down. And then make sure that you have recorded all of your findings, all of your data. You don't want to walk away and go, oh, shoot, I forgot this, that, or the other thing. And then when you get back to the office, you're obviously going to analyze the data, and not just what you got from the audit, but really everything. And then you'll go ahead and start to recommend the changes. So that wraps up our module on doing a site evaluation and conducting an irrigation audit. Lots of resources available to you. And thank you very much for joining us.